what we should probably do now, what would be prudent, and hopefully what will work, is we should probably actually run these tests. I mean, we should probably have been doing that all along, but let's try it now. Wow. Okay. So actually, maybe that's right. Test copy fails, flip to string fails. We haven't written that test yet. Test list stack, that should not fail. So we should be concerned about that one. Equals hash code is full, is empty. So the only one we need to be concerned about here is this one. Okay, so this makes sense, right? This should be capacity here. Okay, now let's run that again and make sure list stack passes, which it does. All right, and the other ones we just haven't implemented yet, so that works out. All right, so far we're doing pretty well. We've got the iterator and hash code. So what is important about hash code? Well, if two objects are equal, well, actually, right, if two objects are equal, they should have the same hash code. Let's test it this way. Let's just say if I shouldn't say if two objects are equal. If two objects are equal, I'm sorry. If two stack objects are equal, meaning that they have the exact same elements, they don't have to be. The elements don't have to have the same references. They don't have to be identical elements in the sense of identity, object identity. Those elements just have to have the same values. So, for example, if I create a new stack, equals new list stack. I need the diamond notation in there. And okay, what's wrong with that? Cannot infer type arguments for list stack. Okay, that's because I didn't put something in there. So I hope you can see that this is an empty stack. This S is an empty stack, and it should be equal to S0. So if these should be equal, they should also have the same hash code, right? No matter what that is, they should have the same hash code. So I'm going to say assert equals S hash code and S0 dot hash code. Okay, and that's going to be my test for hash code. And then test copy. So I'm going to copy this stack. Let me just try to remember what copy does. Copy returns a brand new stack that is a shallow copy of this stack. So when I return that brand new stack, the stacks will have the exact same objects based on object identity, the exact same objects on the heap. So what's a nice little test for that? Let's try this. And again, these are, subjective. You just use your own judgment sometimes as to what the best test is. I'm going to say S equals a copy of S3. I'm going to save that. And let's see. I'm going to do the test this way. I'm going to actually pop elements from S and S3. Again, you can use your own judgment of how you want to do this. I'm going to say string 1 equals s.pop. And I'm going to say string 2 equals s3.pop. And then I'm going to do this. I'm going to assert. Okay, I'm going to do two things here. I'm going to assert equals string 1 and string 2. Okay, because they both should be equal. They should both be the element C. But actually, I can do something even stronger than that. I can do assert true that string 1 is the exact same object as string 2. Because remember, this assert equal uses the equals method for string objects. Okay? Whereas this equals equals, this is object identity. And since this is a shallow copy, they should actually be the same exact object. Now, because I've done it this way, this is really redundant here. Because if something is equal, it should certainly be equals. Okay? If you did your equals method correctly, and since this is a Java string equals method, I'm pretty sure they did. So I can actually comment this one out. And let me just run this and make sure it works, because you just never know. So run list stack test. Where is the test copy? Okay, so test copy is working. All right. So let's test flip, and actually I'm going to test flip on both. Okay, so let's test flip two ways. Actually, let me go back and check what exactly flip does. I can't remember if it flips it in place or it flips it onto another object. I think it flips it in place, actually. Flip reverses the elements in this stack. Yeah, so it flips it in place. All right, so I'm going to call it, let's first call it on S0. And then I'm just going to make sure that S0 is still empty. Okay, so I'm going to do the same thing here for S3 or a similar thing. And then S3 is ABC, C is at the top of the stack. If I flip it, A will be at the top of the stack. So I'm just going to go ahead and pop an element from the new S3 here, the flipped S3. And I'm going to check if that element is A. Okay, str, and I'm going to check if we've got two elements remaining in S3. Okay, so now test is empty. Yeah, I'm going to do a quick test of is empty. Let me see here. We've already tested if this is empty. We've already tested if clearing a stack empties it. So test is empty. No, I'm not going to test is empty. I am going to test is full. Okay, so assert false S3 is full. And then S3 push D, S3 push E, and now S3 should be full. So assert true, S3 is full. Okay.